In this session, we are going to discuss different types of line coding and regarding pulse shaping techniques. Like for a given data, we can express how you can define different types of the line coding techniques and how you can express the pulse shaping technique for the given digital data. For example, the digital data is given 110010. And if you say that you want to represent that digital data in form of unipolar and the pulse shaping is non-return to zero, unipolar, non-NRZ. So we know that in unipolar, non-return to zero, the amplitudes are either zero or positive A. So you represent zero with zero and you represent a with 1 with the positive A, and the pulse is not returning to 0. So like here it is 1, so you can just draw the graph line here. So this is the amplitude, y-axis is the amplitude and the x-axis is the time. So, so here you can write the bit duration TB, 2 TB, 3 TB, 4 TB, 5 TB, and then up to 6 TB, because you have approximately six. You have a six data bits. So you can write each data bits one by one. So here it is one. So 1 0 0 1 and then 0. So as I said, if it is unipolar NRZ, so you represent one with amplitude positive A. So for this one, it is positive A, and then it is not returning to zero. The next bit is again one, so it is still remain positive A. Next bit is zero, so then it will return to zero, and the amplitude is zero. Next bit is zero, so it is again zero, the next bit is 1, so it will moving toward positive A, and then the next one bit is 1, so that is why it is positive A, and the next bit is 0, so then the amplitude is 0. But if you want to represent the same data for the polar and the non-return to 0, and you know that in case of polar you have two values, a positive A and the negative A, but the pulse is not returning to zero. Positive A for 1 bit 1 and negative A for bit 0. So this is the data is given. So first bit is 1, so that is where the amplitude is positive A. Second bit again 1, so that is why the amplitude is again positive 1, and then the third bit is 0, so that is why the bit is returning to the negative value, so that is why it is negative A. So and then next bit is again 0, so it is not returning to 0, the amplitude remains same, that is negative A, and then the other bit is positive 1, so that is why the pulse is moving towards the positive A. So and then the next bit is 0, then the pulse is moving toward the negative A. Similarly, if you want to represent the same data using bipolar and not returning to 0, so the pulse is not returned to 0, but the line coding is bipolar. So it means that for the bipolar case, you are representing 0 with 0 and 1 with alternate representation. If it is positive A, then the next one will be negative A. As we have explained bipolar in our previous session very well, that it need one bit for the memory, because it need to memorize what was the first assignment. Either it was, if it was positive, then the next assignment will be the negative. So let's see how we can apply this bipolar energy to the given data. First bit is A, so if it is A, so the positive assignment positive A. Second bit is again 1, so it means that it is negative A assignment, and the third bit is 0, so that is where the amplitude is 0. The fourth bit is 0, then again the amplitude is 0. The next bit is 1, so you need to see which was the first assignment when it was 1. When the bit was 1, the assignment was negative A. No, the bit is 1, so it means that you have to assign positive A. so that is why it is positive 1, and then the next bit is 0, then you are assigning 0 value. So for the bipolar, you can say that the data level is 2, but the assigned signal level is 3, like 0, positive a value, and the negative a value. And then other type is the return to 0, like the pulse is returning to 0. So again, for the unipolar line coding, so if it is returned to 0, so it means that half of the duration, if the value is 0, if the bit is 0, so the amplitude remains 0. But if the bit is 1, then the amplitude is positive a for half of the duration and 0 for the other half of the duration. So let's see how we can implement this type of data for the unipolar, and the pulse type is returned to 0. The first bit is 1, so you can see the first half of the duration, bit duration TB, you can see the amplitude is positive a, and the next half the amplitude is 0. Second bit is again 1, then you can see the amplitude is positive for the half of the duration and the 0 for the next duration. Third bit is 0, so remains 0. Fourth bit is 0, the amplitude remains 0. Fifth bit is 1, so that means that half of the duration the amplitude is positive a, and for other half the amplitude is 0. And the sixth bit is 0, so that is why amplitude is 0. So if we apply same data for, and the technique is polar and return to 0, we know that if it is polar, then we are assigning two level, positive a and a negative a. Negative value, if the bit is 0, then we assign negative a. If the bit is 1, then we assign positive a. But if it is returned to 0, so it means that for half of the duration we apply positive value, and for other half the amplitude is 0. Like first bit, you can see the half of the duration you apply positive a, and then next half it is 0. Next bit is 1, so you apply positive a, and then the next is 0. The other bit is 0, so if it is 0, so it means that you apply negative a for half of the duration and 0 for other value. So the other bit is also, fourth bit is also 0, so it means that you apply negative a for half of the duration and 0 for other half. Fifth bit is 1, so it means that you apply positive a for the first half of the bit duration and 0 for the next half. Sixth bit is again 0, so it means that you apply negative a for the first half of the duration and 0 for the other half. So if you discuss the same data for the bipolar, and the pulse shape is returned to 0, so we know that for bipolar case you are using three signal level for the two data level. So either you can apply 0, or you can apply positive a and a negative a to the alternate bit if it is 1, and you can apply 0 if it is 0. So similarly, you can see if the first bit is 1, so first half of the duration is a positive a, and the second half is 0. Second bit is 1, so you can see it is negative a for the first half of the duration and 0 for other one. Third bit is 0, remains 0. Fourth bit is 0, remains 0. Fifth bit is 1, so that is why the first assignment was a negative a, so this should be positive a. So you assign positive a for half of the duration and 0 for other value. Sixth bit is 0, so that is why the amplitude remains 0. Now the same data is applied for the Manchester. If the pulse shaping is Manchester and the line coding is polar, so for this you can see that if it is 1, then you will go from high to low. If it is 0, then you will go from low to higher. So first bit is 1, so it means that from first half of the duration it will go from positive a to negative a, and then second bit is again 1, so it means that it will go again move from lower value to the higher value, and then for the other half of the duration it's moving to the negative value. The other bit is third bit is 0, so it means that it will move from lower to higher value. So that is why it is lower, and then for the next half of the duration it is positive, from moving from lower to the higher value. The other bit is also 0, so it means that it will again moving down and then again moving up from the next half of the duration. The other bit is fifth bit is 1, so that is why it will keep a positive value for the first half of the duration and the negative value for the second half of the duration. Sixth bit is 0, so that is why it will keep moving from lower to higher value. So that is for the first half, it will be low negative value, and then for the second half, it will be positive value. So this was the pulse line coding technique for the different type of pulse shaping techniques, and how can you apply these techniques together. So I hope that you understand the application of different types of line coding technique with the pulse shaping techniques. So if you have any question, you are most welcome. You can ask your question in the comment box, and we will try our best to answer your question. Thank you for watching the video.